Okay, this is ENGR 312 Fluids Lab number 7. Okay, today we're going to talk about a lab measuring the frictional head loss of the pipe. Okay, we want to study the loss due to pipe diameter, due to the pipe length, and also due to the flow rate. Okay, so in the measurement, we're going to measure frictional head loss, okay, for a portion of pipe. Then we find the relationship between these factors. Okay, so let me share my screen first. This is the handout. Okay, this is the handout I will post in Moodle. Okay, it's experiment number 7. Okay, it's not number 1. Number 7, frictional hair loss measurement. Okay, so the objectives is to find the frictional hair loss in the piping system, find the relation due to the pipe length, pipe diameter, and the flow rate. Okay, and then we'll compare with measure the data with theoretical analytical calculation. So for the measurement, okay, let me show you the device, the equipment first. So this is equipment. Notice here you have 4 parallel pipes. Here I marked the blue color. Okay, let me make it larger. Oh. Okay, here. Notice here, this is the pump. Okay, the flow in the pipe is driven by the pump. Okay, the pump has suction discharge, right? Suction and this is discharge. Then it goes to the piping system here. Okay, notice there are a lot of valves. I circled them. Okay, in the experiment, the first part of the experiment is to determine the frictional hair loss due to the pipe size. Notice these 4 pipes has different sizes. The top one is 1 inch, the largest, 3/4 of the inch. The second one, 1/2 inch, and 3/8 of an inch. Okay, the bottom is the smallest pipe. Okay, so when we run a measurement, an experiment, we turn off 3 pipes and leave only 1 open. Okay, we maintain the same flow rate. The flow rate meter is somewhere here above it. Okay, in the around that area at the end of the picture. I think it's outside of the picture. It's a flow meter. I think it's outside the picture. Let me erase my. Okay, here, this is the flow meter. Okay, so the outside of this scope a little bit. Okay, you see a flow meter to show you. Eventually, the flow goes through one of the 4 pipes, then go up and go through the top pipe and then go back to the reservoir. This is the reservoir down here. Okay, the white reservoir down here. Go back and then go across a flow meter. It will show the flow reading in terms of GPM, gallon per minute. Okay, so during the experiment, there will be 4 separate runs. Okay, you need to make sure the valve open and close correctly to ensure the flow only goes to 1 pipe, one of the 4 pipes. Okay, the valve vertical to the pipe is closed. Parallel to the pipe is open. Okay, so you close and open the valves to make sure it's open. It only goes to 1 route. Okay, from here, from this setup on the picture, you see the flow is actually goes through this pipe only. See, this is blocked. This is blocked. Okay, this one is blocked, and then it goes through this. This one two are open, then it go up here. Okay, so this is blocked, this is blocked. So top two pipe, there no flow either. Okay, so this is just example. So if you try to measure the ½ inch, you set up like this. If you want to try to measure the bottom one, you want the flow goes through the smallest pipe, you have to close out this left valve and keep this one open. Okay, so that's how to set up the flow. Okay. This is the pressure transducer. Figure 2 shows the pressure transducer here. These are the two pressure transducers. This thing, the measurement actually, the transducer related to eventually will be connected to the computer. And this is the computer screen. This shows you the two pressure readings. Okay. So on each pipe, you have two measurement points. Pressure gauge, you can insert into 2 points. Okay, there are also a reading in the middle. Okay, so if you want shorter pipes, you can pick these two to measure pressure differences. Okay, so pressure gauges. This is a 48-inch. Okay, the longest, the half is 24-inch. Okay, so what you can read is two pressures. So you can calculate the pressure differences, right? So can you convert this pressure difference between these 2 points into head loss? I think we did a pump lab already know. Pump head is calculated by the pressure difference divided by the gamma, right? Okay, same thing here. This equation 2 shows you from measurement point of view, if you want to measure the head loss between a portion of pipe, you find the pressure difference divided by gamma. Okay, so that's the equation to calculate the measured head loss between 2 points for a portion of pipe. Okay, equation 1 obviously is the Bernoulli equation, right? So it shows you the Bernoulli equation between the 2 points. You see, notice there's no pump involved. So the starting point 1 and ending point 2 is your 2 measurement points. Okay, so there's only head loss in between these 2 points. Okay, so because velocity is the same, elevation is the same, that's why it leads to this equation to measure the loss. Okay, delta P divided by gamma. Equation 3 is just the flow rate equation. Everybody knows velocity times area. So this is you measured the loss. So how do we compare to the analytical solution? This is a theoretical head loss equation. Darcy-Weisbach equation, right? H equals to FL over dV squared over 2G. So you need the velocity, which is bred from the flow meter. GPM, the flow rate, you can convert into velocity by equation 3, okay? Pipe diameter are here. So from the flow rate, you can find the cross-section area, right, by the diameter. So you should be able to find the velocity. L is given, right, 48, or some cases 24, okay? So F, you need to find your friction coefficient from Moody diagram. But this is easy case. You have the velocity, you have the Reynolds number, you should have the surface roughness, okay? This is the brass pipe, okay? Brass, so you should be able to find the surface roughness. With the Reynolds number, you should be able to find the F, friction coefficient, okay? So this is a theoretical loss based on the flow rate, based on the length diameter, okay? Based on the velocity. Not really flow rate, velocity, okay? And based on the material, you find F, right? Okay, so compare. So I think the goal is eventually compare your measured frictional head loss with the theoretical frictional head loss. Okay, so you have 4 pipes. For I think the first task here is to study the pipe size difference. So you have 4 different pipes. You should have 4 measured loss for the 4 sizes, right? And you have 4 calculated loss based on equation 4. So I want you to produce, the first one is to produce the plot diameter versus HF. Okay, so diameter, smaller the diameter, the greater the loss. So it should look like this. You have 4 diameters. It should be like this. That's one line. You should have the other line is from the theoretical calculation. 2 lines. Okay, each line have 4 points, 4 diameters. So that's a comparison between measured hair loss and theoretical hair loss. Okay. Oh, they have a flow meter picture. It's in the top and end of the system. Okay, this is the flow meter. Okay, so this is the first one. The second one, I wanted to see the hair loss due to the length. Okay, so we choose a 1/2 inch. I think I choose a 1/2 inch pipe to compare the loss due to the length. So what we do is we measure the pressure loss between the first 2 locations, which is 24-inch distance. Okay, so we also measure the pressure loss due to 48-inch. Or the other way is you can measure the pressure difference between the second 24-inch. We can add them together, become 48-inch. Okay, so compare 24 and the 48. So you have a plot with only 2 points. This is the length, this is, okay? The longer it goes, I think the more loss, okay? You have 2 losses. One is 24, one is 48, 2 points. So also you have a calculated theoretical curve between these 2 lenses. Okay, that's the second task. Loss due to the length. The third one is the loss due to the flow rate. Okay, in this case, you also pick one pipe 1/2 inch, then go through the top. Okay, top pipe. Then you can control the flow rate. There's a valve around here. Okay, at the end of it, actually, there's another valve to you can adjust the flow rate. You open and close the valve to adjust the flow rate. So you will have 5, 6 different flow rates. Okay, the greater the flow rate is, the more loss. You should have also a plot like this. Okay, 1, 2, 3, 4, 5 or 6. I forgot the data. Also, another curve for the theoretical one. Okay, so I think we'll still go through the 1/2 inch pipe only. Okay, we don't want to change too many parameters, right? We pick one pipe and we change the flow rate. And then there will be 5 different flow rates or 6 different flow rates go through this 1/2 inch pipe. Okay, so every time a flow rate goes to it, you measure the pressure difference, you calculate you measure the measured hair loss. Okay, then you use theoretical calculation to calculate the analytical, theoretical hair loss, okay, to compare. Okay, so this is task number 3. Okay, so this experiment, we do it, it's kind of long. It takes about ½ an hour for each group to do. Okay, so you will have total how many measurements? So for each pipe, for the first task, you have 4 measurements. Okay, 4 experiments, 4 measurements. Then for the second one, you have 2 measurements, a total 6. For the last one, you have another 6 flow rate readings. So a total 12 measurements of delta P, okay, of the hair loss. So I think the requirement is clearly shown. I can clearly return to here. Okay. Friction loss versus size, friction loss versus length, friction loss versus flow rate. Okay, so these are the plot report requirements. Okay, basically, I think the key is to produce 3 plots, compare between measured values and theoretical values. Of course, need some discussion, right? To if they agree with each other, or if not agree with each other, what's the physics behind it, what's the reason, okay? And okay, so that's our lab number 6. Oh, number 7, lab number 7. Okay, I will post the lab before class next week, and then you will have 1 week to do the lab. Okay.